Hi guys, it's the start of chapter 13 and some nice GCSE topics actually. So you'll recognise tree diagrams, Venn diagrams, and actually sample spaces is from way back, maybe even primary school. So I'm not going to do sample spaces with you today. If you need any help, please let me know. I don't actually think you will. I'm going to focus on these two topics because these are the ones you're most likely to have come up in the exam. So I'm starting off with a really nice tree diagram question. One without replacement, which means once I've chosen the ball out the bag, I'm not putting it back in. I'm noting the colour, I'm putting it to one side, and that will have an impact on these probabilities here. So let's have a go at filling this in. When I first choose a ball out the bag, there's 17 of them, 7 are red. So I've got 7 ways out of 17 for the ball to be red. I have 10 ways out of 17 for the ball to be green. Now, my second option, if I chose a red first time, that's going to impact the number of red I've got the next time. So I've only got 6 red now out of 16. But because I chose red, I've still got the original 10 green balls. And what you'll notice is that adds up to 1, as it should do. That adds up to 1, as it should do. It's either red or green. There's not another option. Here, it's either red or green. Again, there's not another option. Now, let's look at this route here. Imagine you chose green first time. Well, if you chose green first time, you've only got 9 of them left now out of 16. But because you chose green, you've still got the original 7 red balls, but there are now only 16 to choose from. Now, if I want to work out probabilities of choosing 2 red balls or a red and a green, for example, I want to multiply along the branches, and I'm going to fill in all 4 options here. So there are only 4, but these probabilities here will be different. So, red and red, if I multiply the probabilities here, and that's 272. Then red and green, 7 over 17, 10 over 16, that's 7 over 272. Green and red, we'd expect to be the same, wouldn't it? Because green and green, same probabilities. And it is actually the same. And then the last one, 10 out of 17 and 9 out of 16. I'm not reducing these probabilities because in a bit I might want to add some of these together. It just makes it easier to leave them as they are. This will also add up to 1. Because you've covered all 4 outcomes. So let's answer some questions about these. I want the probability that 2 balls are the same colour. So that means I could have a red and a red, or it would also be fine if I had a green and a green. Now what you have to remember, this is back at GCSE. If you've got an and question, it's a times. If you say or, it's a plus. So when we did red and red, it was a times. I now want red and red or green and green. So I'm going to do the probability of red, red, or the probability of green, green. And keeping those probabilities with the same denominators is making it so much easier to add here. 132 at 272. And I probably would simplify that down at the very end. I haven't got a calculator with me, so I can't have a go at doing that right now. I know I could divide by 2, but maybe that's something you can finish off for me. Now this question here, this is at least 1 green ball. Well, if I looked at least 1 green ball being in the outcome, it could be that, it could be that, it could be that. So I can add all three of those together, or hopefully you've kind of spotted a little shortcut here. I can just do 1, take away the probability that it's red. Make sure you look out for those kind of shortcuts, because otherwise in the exam you could be doing a lot of calculations, taking a lot of time, and you really don't need to. So that number there, that fraction, is exactly what I'd get if I added those three together. Okay? Right, let's have a little look at Venn diagrams. Again, we've done these at GCSE. We've looked at all the notation, but it's worth having a recap. I'm going to start from the bottom up, because that tends to be where most of the valuable information is. I've got a Venn diagram here that shows how people take their coffee. 31 people take neither, so 31 goes in there. That's outside the circles for milk and sugar. 20 take both. Remember, both and is the intersection of the two. So milk and sugar there is 20. Now a common mistake would be to put 83 in there and 30 in there. But what you've got to remember, 83 is that entire circle. And we've actually already accounted for 23 people. So I'm not going to leave 23 in there. I'm going to put 63 in there. And same over here. 30 people take sugar, but I've already accounted for 20 of those in the milk and sugar. So that becomes a 10. Now we're going to have a go at some questions from here. And let me just pause this, and what I'm going to do is fill in those numbers again. So it'll look to you like they appear by magic. Wasn't that amazing? Just appeared. Okay, so probability of S. So this is a probability that a random person takes sugar. Well, there are 30 people who take sugar. So it's going to be 30 out of, and altogether 31, 63, 20, 10. That's 124. Probability that someone takes milk and sugar. So if you don't remember that, that is an and. That's an intersection. So that's an intersection symbol. That is an or, and that's called a union. So we want the people who take milk and sugar. Well, that's that intersection there. So 20 out of 124. Milk or sugar. So this is the milk and sugar. That's the milk and sugar. That's the milk. That's the sugar. That's neither. So milk or sugar will be the circles combined. So 63 plus 20 plus 10, 93 people out of 124 take milk or sugar. You could actually work out the same by doing 1 minus the probability of neither. So that's the same, isn't it? So if you take that away from 1, you get everything in there. This down here, this is not milk. So what is the probability that they do not have milk? So I'm going to just shade in the milk section there. So we want everyone who's not in that section there. So that would be 41 people out of 124 do not take milk. Now I'm going to look at the next bit, which is milk and sugar not. Well, we've already done milk and sugar, and that was 20 out of 124. So milk and sugar not would be everyone who's not in that intersection there. So it could be people who take milk and not sugar. Could be people who have sugar and not milk. Or it could be people who have neither of those. So that's going to be 104 out of 124, which is 1 minus the probability of milk and sugar. So that little apostrophe there means not. Now, something just to notice, the probability of milk or sugar is the same as adding the probability of milk plus the probability of sugar. Take away the probability of them both. It's probably obvious to you, but there will be a formula related to this. So if I want M or S, which we got was this, that's the probability of milk plus the probability of sugar, take away the intersection. Okay, because if you think about it, if you add that and add that, you've added that twice, so you have to take it away. If you have mutually exclusive events where the overlap is naught, then that would be naught. You're not taking away anything. So you get a slightly different formula, which is just the OR law. And I've got quite a few of them here. I've already done your symbol here. That is what I've just mentioned. So the probability of A or B is the same as adding the two individual probabilities, making sure you take away that intersection if you haven't already. And if they're mutually exclusive, like it says here, there's no overlap. Your circles wouldn't overlap. And that would be naught. So you would just get this law here. Independent events do overlap, and it means one event doesn't affect the chances of the other. And if you've got two independent events, you have the AND law. These are all things from GCSE, it's just a recap, but they're there for you if you need them. I'd like you to try the questions now from the chapter checklist. I think I've asked you to do them all, to be honest, because it's all good practice and it's all prior knowledge. If you come across anything that you really can't do, please let me know and I'll do the question sort of live on a video to help you, or I'll send you photos of it. Whatever you need, I'll help you with those. The next video is something completely new, so I'm expecting you to find the next topic a lot more challenging. So best of luck with that for now. I'll see you hopefully as soon as possible, but please carry on taking care of yourself, washing your hands, keeping safe, and hope to see you all soon. Bye for now.